So thank you everyone for joining our workshop on Scaffold-eth with Kevin, developer advocacy at Scaffold. And we are also with Northern Virginia Community College Blockchain Club and the Northeastern Blockchain Club as well. So a few words about Dapps. Dapps is a 501c3 nonprofit that aims to accelerate blockchain education and awareness. We are launching accredited classes on educational meetup like this one. And this year, we try to boost blockchain clubs by connecting them to sponsor, connecting them to speaker, giving students free ticket as well. And FYI, Nir and Algorand help us keep running, so big up to them. And if you are a student, we have few free tickets to Consensus, so I'll drop the links. And we are doing also an Algorand web series. I'll drop the links in the chat if you're interested. So maybe Matthew, if you want to introduce your club, you can go ahead.
Yeah, so my name is Matthew Krill, founder and president of Northern Virginia Community College Blockchain Club. This is our first semester together. Looking to learn, be excited. I'm pretty excited to be a part of this event.
Should I introduce myself now, or?
Sure, go ahead.
Okay. Well, I'm Alex Beaudry, not to be confused with the other Alex on stream, but I'm the director of events at NEU Blockchain, which is Northeastern University's blockchain club. We've been around for, I don't know, what is it, 2 years now? I think we started 2 Augusts ago. But yeah, we're doing a lot of fun stuff. If you're in Boston, let us know. Like, happy to meet with you. Alex, anything else to add? Like, what are the stuff we're doing, and what's your role there?
I'm Alex Leth. I do the I'm director of the tech team for the Northeastern Blockchain Club. Yeah, we do like hackathons, projects for the tech team. We've got like governance, education, all kinds of stuff going on. So it's a good time, and yeah, super happy to be here.
And yeah, I'm VP of Virginia Tech Blockchain. We're trying to make some new connections with other organizations, so hit me up on LinkedIn.
Thank you so much, guys, for coming to this talk, and everyone that's tuning in. Really excited to be here today. I'm going to teach you guys all about what it means to build on Ethereum. I'm going to be talking about a really awesome toolkit called Scaffold-eth. If you guys haven't heard of it, it's basically kind of like the go-to toolkit for if you want to build on a EVM system and you don't want to have to like go out and grab all the parts like here and there and piece them together, and you're kind of like trying to prototype and like build quickly. Scaffold-eth is kind of like the go-to thing for that. So I'm going to go ahead and share my screen actually right off the bat here. I don't have any like slides to show or anything crazy like that. I'm just going to kind of dive right into it. We're going to talk about how you can get Scaffold-eth, right? So if you do a search for Scaffold-eth, one of the first links that's going to come up is going to be the GitHub repository. And by the way, I apologize to everyone. My voice is a little messed up right now because I'm just getting over being sick. So if it would have been 2 days ago, I wouldn't be probably being able to talk at all. So hopefully you guys can still hear me okay. But yeah, so Scaffold-eth is available on GitHub. It's open source. It's a public good, and yeah, it's really simple and easy to set up. Scaffold-eth is kind of like the brainchild of Austin Griffith and a organization of developers maintain it called the Build Guild. So if you haven't heard of the Build Guild, the Bugle Guild, as you would call it, the Bugle Guild is exactly that. It's a collection of builders, Bugle Guild, that they kind of come together and they basically contribute to the Scaffold ecosystem by providing builds or enhancements to Scaffold-eth. And you can actually join the Build Guild if you go through speedrunethereum.com. You can kind of think of Speedrun Ethereum as kind of like this kind of validation of your skills to being able to build a decentralized application on Ethereum. If you sign up for Speedrun Ethereum, it's free, and you can kind of get verified by going through these kind of like challenges and building different projects like an NFT or a staking app or a token vendor, and you kind of eventually make your way to joining the Build Guild. And the Build Guild is, again, it's a public good, and it's designed to help the ecosystem grow by incentivizing builders to help the community around it. And you can actually set up a stream if you're good enough and you're active enough, and you can actually get paid in ETH to contribute to the community. So check out Build Guild. That's just my quick shill there. So back to Scaffold-eth. The GitHub really has everything you need to know to get started. I'm going to be going through a quick demo and kind of build a Dapp with you and show you kind of like what the process is like. But if you're getting started, this is going to walk you through here in the documentation on where to go and where to get started from there. Once you kind of get set up, you can do two things. You can dive right into speedrunethereum.com, or if you want to get a little bit more specific on Solidity, which is the backend programming language for the smart contracts, then I recommend checking out Solidity by Example. Solidity by Example is kind of like this go-to place to find examples of how you do different things with different directives and different variables and configurations. And this will give you a good kind of like solid understanding of how Solidity works. And then Speedrun Ethereum will give you a good solid understanding of how Scaffold-eth works. So it's kind of a two-part thing. So I've gone ahead and I've already checked out the repository here. So I'm using tmux. If you guys don't know what tmux is, it's basically just a terminal multiplexer. It allows me to have multiple windows open in one window. So that's why you see 3 windows. You can just do all this in different windows. You always kind of need like 3 windows up in Scaffold-eth, sometimes 4, but for the most part, you need 3. The first one here, I've gone ahead and let's check it out. We've already gone ahead and checked out the repository, and I've already installed that, okay? The next thing I did is everything in Scaffold-eth also is built around Yarn, okay? Yarn is a package manager, and it essentially allows you to like bundle up all of your like requirements into your project. And then you can just do one simple Yarn command like yarn install or yarn. And what it will do is install all those dependencies for you. So when you first check out the repository, the next thing you need to do is do the Yarn install. So do the Yarn install, it's going to do all that for you. So I've gone ahead and did that as well. The next thing you're going to do is to get started and spin up a blockchain. To spin up a virtualized blockchain on your environment is you're going to run a Yarn chain, okay? Yarn chain is going to spin up a copy of Hardhat, and it's going to spin up a copy of 20 accounts that you can use that have like play ETH in them, essentially so that you can like mimic the Ethereum virtual machine, right? Then you're going to go into a new window. So you're always going to have Hardhat open. After that, you're going to open up a new window and you're going to do Yarn start, okay? Just letting people in, so I don't know who's in the waiting room, but welcome. Yarn start is going to spin up a copy of React, okay? So another core component of Scaffold-eth is React. And that's because a lot of the React code and the JavaScript code is already written for you that allows you to get started quickly with a front end that will allow you to kind of like mess around and toy with your contract, okay? So boom, it automatically started up. So we have our contract, has not been deployed yet, which I'll get to in a second, but we do have a copy of our front end, and we also have Hardhat running, which is our back end. So Hardhat you can think of as your smart contracts. Your front end is going to be Scaffold-eth, which is running in React. And we can see right away that we have these kind of like tabs. So we can go through these different tabs and click through. This first one is the app home directory, okay? It's basically where you're going to build your Dapp or your decentralized application inside of Scaffold-eth. So you can kind of think of it as like an app inside of the Dapp. So you build your app inside of here and you can do any of your functionality later. So this is just showing you some little tips and tricks on where you get started to edit this, where your contract's located in the file structure, which I'm going to show you in a little bit, how to deploy, which we're going to get to. And then this debug contracts is where the secret sauce is for Scaffold-eth. And what you'll notice is this debug contracts is showing that we don't have a contract. There's nothing loading. So let's go back to our deployment here. React's up, Hardhat's up, so we're going to leave both those windows open, right? And then we're going to come down to our last window, and we're going to do a Yarn deploy. So you can do a Yarn deploy, and that's going to take a copy of a smart contract that comes with Scaffold-eth and push it to Hardhat. So we can see it deployed successfully, and we can see that we got an address, and we can see how much gas that it costs, which we're not going to get too much into gas, but that's how much it costs to actually publish this smart contract to our private network or our private blockchain. And we can see now, if we come back here and hit refresh, we should get a copy of our contract. So we do. We get this kind of cool contract. It has an address, which is, sorry, let me hide these meeting controls again. So it's got a copy of the address. It's got, shows you how much value. It's got a variable called purpose, and it has a value, and then it has a function as well that's already created as well. So let's take a look at this, what this contract looks like, okay? So let's go here and let's do code dots and load this up in VS Code. And let's go into, let's show you what the file structure looks like real quick. So first thing you'll notice is there's this packages directory. So if you're familiar with yarn, you have this packages folder where you can have different yarn repositories, okay? And we have 3 different ones that are important. One is Hardhat, one is React app, and then one is just your services. And there's also subgraphs, but we're not going to get too much into that as well. But the one I want to talk to you about right now is Hardhat. So where your contract, this like starter, it's kind of like a hello world contract is inside of the contracts folder inside of Hardhat. So let's take a look at it. It's a very simple smart contract. It just has a version, it has a name, it has the event to basically publish an event when something happens to a function, and it has a string, and it has a empty constructor, which means that it doesn't do anything on the deploy, and it has a function that allows you to update the purpose. So the first thing we could do is we could change this just to like building awesome apps or something like that. Save it, and then we can come back here and redeploy, but we can force a new deploy with reset. So if you just did yarn deploy, it's going to check if any changes were done, and it's going to deploy only if there's changes. If we want, you can just reset, and we can get as many deployments as we want over and over, and we can know that we're getting a fresh copy of the contract. So let's go back to our front end, and we can see that our front end adapted. It saw that I changed that hard-coded in the Solidity file, and it's available here. I could also update it here if I want. So I could say set purpose, BAF is awesome, something like that, right? And I could hit send. And it's going to tell me, well, I don't have enough funds to pay for this transaction. I need to pay some money, right? This is a blockchain network, right? In order to change state, you got to pay with some gas. So I can see here that what happens really cool is I have a wallet at my disposal. Sorry. I have a wallet at my disposal that's inside the browser. So I don't need to connect to MetaMask or my Wallet Connect or Coinbase or whatever I need to do. I can just use this burner wallet. This is a really cool part of Scaffold-eth as well, where there's a wallet that's stored inside the browser. And there's this awesome button here that just allows me to get funds from the faucet, and that pulls money from Hardhat, sends it to my burner wallet, and now I can hit send, and I can update the state of the smart contract. I can also even come over here, and I could say file new incognito window, and I could go to the same address, and let me do that, and let me bring this over here. And I can notice that I get a new burner wallet. So I have this little kind of blue, purple blocky dude or green blocky dude. And then over here, I have a purple blocky dude, right? So I can grab here and I can grab some funds as well, go to debug contracts. And I could say like, no, Kevin, it's cooler or something like that, right? And I could send. And then I could, because I have access to the smart contract on these different wallets, and I can instantly start testing kind of like my assumptions on how my smart contract should operate. Okay, so let's leave this kind of like incognito tab open because we're going to utilize that a little bit. But let's show here that we've been able to kind of just change the state of the contract manually, right? By going into the actual smart contract and then redeploying. If I was to come over here and just do a redeploy again, we would kind of reset it back to the way it's supposed to be. And then I would need to rechange the state again, right? But what I want to show you now is that you might want to do something interesting in your smart contract that is maybe like access control related. And so back in the day when like people first started building on Ethereum, what you would do is you'd start building out your smart contract, right? So you would do something like this. You'd say, all right, well, I want to define an address. I want it to be publicly available, and I want to call it owner. And I want it to reference my burner wallet address, which is right here. So here's a copy of my burner wallet. I can come over here and I can paste that in. Let me paste it like that and save. And let's go ahead and redeploy. And then what we'll also see is that we were able to successfully deploy. And then we can see that now our contract has this new variable called owner. Well, so now I can go a step further and I can say, well, let's require that anyone that wants to change this function is actually the owner of the contract, right? So the next thing you'll learn is you'll want to create an access control or maybe a message value control of your function, and you'll use the require statement in Solidity. Okay, so we're going to say that we're going to require that the message.sender, which is the global available message.sender, is basically a global variable that's available to at the time of the transaction that checks to see who signed the actual message or the transaction. So we have access to that when a person calls the function. So we can use that variable to say, make sure that message.sender is equal to the owner. sorry, like this. Otherwise, you are not the owner, something like that. I don't know. I spelled that wrong. Okay, so let's save that. And then we need to end it with this. And then let's go ahead and redeploy. Okay, so we've set up this kind of like owner variable, and we've basically set this kind of rule that says like, all right, if I want to change this, I need to be the owner. So I am the owner like this, and I can hit send. It let me. If I come to this incognito tab now, I have a different profile, I have a different signature that I'm signing. So I should be able to come here and say, I am not the owner, like this, and hit send. And it does not allow me. You are not the owner. So I've been able to set up this kind of like janky access control. Okay, now that's not the proper way to do access control. The actual proper way to do access control is to utilize what's called OpenZeppelin's ownable contract. Okay, it's kind of like the de facto way that you would set up access control. So what we'll do is we'll get rid of this kind of like hard-coded, like janky way that we did it, and we'll get rid of this hard-coded address here. And instead, what we'll do is we'll use the import command. Now we're already using the import command for the hard hat console, which is allowing us to see all these like pretty messages when things happen over here. But I'm also going to inherit the OpenZeppelin smart contracts called Ownable. Now, OpenZeppelin is a company, but they provide a lot of open source contracts that are kind of like trusted and like verified as being like legit and like verifiable as kind of like the de facto or standard, right? So this is the way you should do access control. And so instead, what we'll do is say that our contract, your contract, is ownable like this, okay? And so what that's going to do is it's going to give us access to everything that's inside that other smart contract. So if we just keep it like that and we save it, and then we go ahead and redeploy again, what's going to happen? Well, it's going to deploy. It's going to give us a copy of the new contract, and we'll see that we get access to an owner variable. It doesn't match the one that we want it to be, but we'll get to that in a little bit. And it also gives us two more functions, because the other, anytime you do an import, you also get to inherit all of the functions, and you get to inherit all the variables. So one of those is renounce ownership, which allows you to like throw away your ownership of the contract, which is really like, if you want to like instill trust in your contract, that's something you would do, is you would like deploy it and say renounce ownership and show that it has no owner and it can live forever. And then transfer ownership is going to allow you to transfer the ownership to another person. Okay, so where is this owner variable coming from? Well, it's important to understand again that Scaffold-eth uses hard hat, and hard hat uses JavaScript to deploy the smart contract. So we can actually take a look at what that looks like. So if we go in here, sorry, let me hide these controls again, and we go into the hard hat folder, and we'll look right below, there's a deploy folder, and inside there is the deploy script. Okay, so again, hard hat uses JavaScript to deploy the smart contract. And so we can see here that we have a chain ID, it requires ethers.js to do this. It gets a copy here of all of the named accounts that are at its disposal using hard hat. And so it's going to use the very, very first one as the deployer for the smart contract. And so what Ownable is going to do is say, okay, who was the first person to deploy the contract, and set that person as the owner. So in this case, we need to change that, right? We don't want the hard hat owner to have, we don't want the hard hat contract public key and private key combo to have access. We want to have it in our burner wallet. So how do we do that? Well, if we look down here in the kind of like comments, one thing you'll notice is that there's some kind of like grayed out stuff that you can just copy and paste. The first thing is this one here, which is going to allow us to get a copy of our contract. So it's going to create a variable called your contract, and it's going to use ethers to get the contract, and it's going to reference the deployer, which is that first address. And then you'll notice here that there's this kind of already, again, built-in way that we can get a copy of the contract transferred using that existing function. So we can call the your contract after we've already got a copy of it here, transfer the ownership to whatever address we want. So let's do that now. Let's go grab that address here. And sorry, I didn't copy it. There we go. And let's go ahead and paste that in, okay? And save. And then let's go ahead and redeploy. Okay, so now we've deployed the contract using Ownable, and we've transferred the ownership, hopefully. There we go. So now we can see here that in our UI, again, it's adapted again, and it's showing here that the owner matches because we transferred it. It's got to reset. It's got all these functions. And so we're kind of, you can see what we're doing. We're iterating and we're kind of adding functions and deploying our contract and transferring the ownership. And we're just really toying around with kind of the abilities that are at our disposal. Okay, the next thing I want to show you is a step further. This is kind of a boring contract. It's not really useful to be able to update a state. It's very useless unless you were like had a blog or something like that and you wanted to update your status or something in this function. So let's close this, and instead of using the ownable, well, we're going to keep ownable. We'll still use ownable, but instead of requiring that someone is the owner, let's do something different. Let's actually require that the message.value of the person calling, or the message of the value that's being passed into this is a certain amount. So we'll set it to price and then say send mo money or something like that. And we'll close that off, and then we'll define price. So let's define price here. So we'll do a uint, which is unsigned integer, public, called price, and we will set it at 0.001 ether, like that. So you can write ether here, or you can write way. I'm not going to get too much into the difference, but the cool thing is if we were to actually like, if we did the math, we could just write out the long format of what the way would be here, but Solidity will allow you to just put ether in there, and it will understand what it is. And so we can see here that we have this kind of require statement now that's going to require that someone, when they call this function, pays 0.001 ether. Okay, so let's save that. Okay, and then it's already a payable function right here, so we know it's going to be able to accept some value. So let's go ahead and deploy again. Get a new copy. Okay, we're deploying. Boom, it's deployed. Okay, so now that we got our new deployment, we can come over here. We can see that there's a new value variable called price, and we can see what it is in way, which is what I was telling you before. Ether and way are kind of like the times 10 to the 18th power division of ether. And so we can see how much money it's going to cost us to set this purpose. So if I come over here and I say, I don't know, Kevin is awesome, something like that. Like boom, and then I didn't send a value, it's going to say send more money. So I need to send some money. Okay. So you think you could come in here and type 0.001 and then hit send. That's not going to work because you need to send it in way. So anytime you're transacting on a smart contract, you need to talk in way. So we actually have it here. But the cool thing is if you want to just type in ether here, you can click this little green button and it's going to do that math for you. So boom, there we go. We hit send. There we go. Now it works. Now, so what's changed? So we have the smart contract that's accepting value. And then up here in the corner, we can see that it actually has some value. It's worth $1.80 now. So the smart contract is acting as a bank. So we're able to actually like, use it and provide some value right now. So if I come over here, this incognito tab, and I can be like, all right, cool. Yeah, let's change it to, I can participate now. I can, whatever. I can hack. Let's do that. 0.001 ether, hit the green button, hit send. Boom. Okay, so now we're allowing anyone to allow in the beauty that is the blockchain, right? Anyone can kind of like come in here and start interacting with the smart contract. But we have this huge problem. We don't have any way to get the funds out of here. So we need to create a withdrawal function because now the funds are literally locked in this contract. So how are we going to do that? Well, let's go back. And you can see what we're doing is we're figuring out, okay, cool, we need to do this and we need to do that. And we're kind of using Scaffold-eth as our kind of like catalyst to do that. So now let's do a function that allows us to withdraw. Okay. Withdraw like this, if I can spell. Okay. Today's just not a good spelling day for me. Okay. All right. So now what we can do is say a require, and then we'll set a Boolean called success. Otherwise, we will not. And then what we're going to do is message.sender.call. So basically what we want to do is we want to just allow this function, which allows us to like rug pull, essentially, withdraw all the funds out of the contract. So I'm going to say that if anyone can call this and they are the message.sender, and they are going to be able to do what's called a call transfer, which is whenever you want to send value from a smart contract to a wallet, you're supposed to use the call function. So I'm going to use .call, and I'm going to pass in the value as the address of this address of this smart contract's balance. And then I'm going to, what else do I need to, I need to add these little like things at the end like this, and then boom. Now there's one problem. I don't want anyone to be able to do this, right? So this is where the ownable comes in, right? We have this ownable access control. I don't want everyone to be able to withdraw my funds, right? I want to do it because I built this smart contract. I spent the time to do it. So another thing you get access to when you inherit and import, when you import a contract, you get access to the inherited functions and modifiers. So one of the modifiers is a way for you to modify a function with some certain rules. So let's add this modifier. It's called only owner. So that's the access control function, or sorry, not function, modifier for a function. And so we're going to say that anyone who withdraws here has to be the owner. So let's save that. And let's see that I make sure I didn't spell anything wrong. Let's go ahead and deploy. I think I did. What did I do? Withdraw. Oh, public needs to be public. There we go. Okay, let's try it again. Boom, there we go. Okay, see, I knew I would mess something up. Okay, so we got the smart contract. So now we can come in here and say, all right, so let's set the purpose to foo like that, and boom. And then I can say bar like this and hit send, and boom, we have some money in the contract. So if I'm this kind of like incognito person here and I see this, oh, this smart contract has a withdrawal function. Maybe I can just kind of like swipe that $3.60 and go buy a beer. So let's hit it, send. Nope, I'm not the owner, so I'm not going to be able to, right? I'm blocked from accessing the smart contract's withdraw function, but because this contract matches this owner variable, I can come over here, withdraw, and then boom, it was successful. Okay, so I'm able to withdraw those funds and put them back in my wallet. So I've kind of created this cool, like kind of like token, not token, but like a vending machine, right, in the sky where I can like do these different things. So let's show you how you can do something really interesting. Is we can take this kind of like, we have this price function. Now, what if we wanted to create like a curve for it? So we could say something like this, where we say like, all right, let's set the price to equal the price times 101 divided by 100. So basically what I'm saying is let's multiply the price. Let's just add 1%. That's basically what I'm saying. Let's see if that works. So with one little small change, right? Now, if I come over here and I try to change this function to like, hey, what's up? Like this, send, it let me, but look what changed. The price changed because we're basically taking that state variable and we're increasing the percentage by 1% every single time. I could do something even crazier. I could say like, oh, okay, price equal price times 2, something like that. Boom. And let's go ahead and deploy that. And just kind of messing around, just seeing like how things work. And so now if I come over here and say, yo, hey, and then hit send, now it's double the price. And if I come over here and say, what's up, and put in the new value, which is going to be this value, and put it there, and oh, okay, and I come back over here, and you can see this is getting expensive, right? So I need to get I need to put 4,000 send. So now it's 8 billion, whatever, 800 billion. I don't know how much that is, but that's a lot of way. So we can see here that we're kind of creating this cool, like dynamic experience with our smart contract. Now, everything we've been doing is kind of like in this state where it's all local. We've been building our smart contract and we're testing locally and we're doing all this interesting stuff. What if you want to go to the next step? Now, let's just say you have the smart contract and you're at this point where you want to deploy it to a test net and you want to like call your buddies and be like, hey, what's up, man? Like, what's up, Vitalik? Can you interact with the smart contract for me? I want to test it. Okay, cool. How do you do that? So the first thing you want to do is you want to do a yarn generate. Okay. Now, the reason why you want to do yarn generate is because using the hard hat accounts is not a good idea because everyone has access to all of those hard hat private keys. Okay. So anyone that has hard hat installed on their computer can essentially use your testnet ether. So you don't want that, right? You don't want to fund those private keys. Any ether that goes in there is withdrawn immediately, trust me. So we need to create a private key that is generated randomly, locally, that we can kind of keep as our secret, kind of like our personal secret, right? And so if we look at our source code here, we'll see that they're down in our like kind of hard hat directory, there's this public key. public address. It's right here. I'm not going to click it because inside of it is essentially the words used to generate the private key. And so if you had those, you could kind of steal the ETH. So that you want to keep that secret. But now what you can do is if I want to deploy to a test net, how do I do that? Well, it's easy. You just do yarn deploy -- network, and then you say what network you want to do. So if I said Goerli like this, well, it's not going to let me deploy right now to Goerli because that contract or that address that I just generated doesn't have any funds. So what do we want to do? Well, we want to use yarn account next. Okay, so we did the yarn generate, then we do a yarn account, and then what we can do is we get a QR code. When you run yarn account, you get a QR code of your public key, and all you have to do is come over here to like one of a burner wallet that you have that keeps all of your testnet ether. So in my case, I'm using what's called Punk Wallet. Okay, Punk Wallet was built with Scaffold-eth, so it's super awesome. If you guys are at home, this is my little Punk Wallet, and basically I've got some Goerli ETH there. So I can click here and click scan, and I can scan my public key on here, and I can send myself, I don't know, let's just send like $20 and send. There we go, transaction started, and we'll just give it 1 second. Actually, so Goerli is, you know, probably about 10 to 15 seconds. There we go, it succeeded. So now I can run yarn account, and it's going to go check all my balances, and then successfully, I should have just sent myself $20 worth of ETH on Goerli. There we go, boom, we have a balance of 0.011111 whatever. So now we have this generated account to deploy. So now we can run our deploy again and see if it works. Yarn deploy -- network Goerli. What did I do wrong? Insufficient funds. Oh no, it must be really expensive to deploy in Goerli right now. Let's try again. Okay, I need to send some more funds. Well, let me send some more. Let me send, I heard the Goerli is blowing up right now, so it could be that's what's going on. Let's send some more. Sorry, let me send like $100. This is the live demos on testnet. You always don't know. All right, let's try it again. Your account. See if we got a little bit more money in there. So basically, yeah, we didn't have enough funds. So now we have a little bit more. Let's try it again, okay? So obviously when you're on localhost, you're using all this play ETH and it doesn't matter. When you're on a test net, boom, there we go. Okay, so now we're deploying to Goerli. So a Goerli is a test network for Ethereum, and we're successfully deploying, hopefully. Let's see if it works. All right, so that's deployed. There we go. It deployed and it told us how much gas it took and it's done. So we have our address here. So now we can go over to our browser and we can go to Etherscan. Actually, we can refresh here. Well, no, first let's go to Goerli Etherscan and let's do a search for our contract and paste it in here. See if it deployed. There we go. It just deployed 23 seconds ago. So it's already, Etherscan's already like hashed my contract. And so we can actually look at the contract and we can see some information about it if we want to, and see, you know, how much gas it took, which we already know. But, you know, more importantly, we've been able to deploy it. Now, the next thing you'll say is, well, okay, well, we're using our React as local as well. So how do we update that? So now this is when you start building out like maybe React a little bit, and you're going to start kind of messing around with React. So let's go into the React folder. So in the React folder, there is a public folder, and then there's a scripts folder, and there's a source folder. So actually scripts is not where you'll be, source is where you'll mainly be. And then inside of views is pretty much where you have like your home JSX file, which is where you build out your application that I talked to you about. That first tab is the home JSX file, but the main Scaffold-eth JSX file is the app JSX file. So let's click that and let's just scroll down just a little bit. And the first thing you'll see is this const initial network, and it's network.localhost. We're going to change that to Goerli like that. Okay, let's save it. Okay, and let's refresh. And let's assume we're not going to change our front end anymore. Okay, let's just say we're going to use this kind of like bare bone thing that's built for us. We're not innovating too much crazy with React. I'm going to do yarn build while we're waiting. Okay, yarn build is going to build out a special build that is designed to be able to published in a low byte size. So anyways, so let's go back to our smart contract and let's go ahead and refresh. There we go. So now we on Goerli. Yes, we're on Goerli. and we can see our contract is here, and we can click it, and then we can click right here. Okay, apparently I've deployed this contract to Goerli. I don't know why that's showing this old. Oh, that's my private key. Sorry, I need to click this one. Okay, yeah, here's the contract, and we can see the contract creation. Hey, here's what I want to talk about. Now, if you look at this contract tab right here, what do we see? It's gibberish. Okay, unless you were like an AI robot, you're probably not gonna be able to figure out what this is for like the next, I don't know, 20 years. This is basically the hash, and it's basically like all the bytecode, essentially, of all the different stuff going on. And so it's impossible to read. So we want people to be able to see our smart contract, okay? So one of the things that you do when you build on Ethereum or build on really any blockchain to instill trust in your smart contract is you wanna make it publicly available. So we're gonna use Yarn Verify to do that. And that's going to basically allow us to verify our smart contract. So let's go into CD, projects, Ethereum, Scaffold-eth. Oh, it's already done. So we've created a build of our project here, but let's do Yarn Verify. Yarn Verify. And then we're going to paste in our address. So here it is. And we're going to do the --network Goerli. Okay. So what this is going to do is it's going to take a copy of our smart contract. It's going to compile the bytecode locally, and it's going to send it off. I think it's going to send it off actually using the API to Etherscan and say, hey, here's my smart contract. Please verify it and make sure that it matches the bytecode that you have already inside of the EVM. Make sure they match. And then if it is, can you just basically give me a checkbox? And so we can hit refresh now. And now we get this green checkbox that says, hey, I'm verified because I submitted my contract for verification. Okay, so we can see our smart contract is here now, and we can see all the functions, and anyone can see that. And so it makes it really, like I said, instilled and publicly available. And so our contract, we've deployed our contract to Goerli. We've created our verified contract. The next thing we want to do is probably publish our DApp. So we don't want to have it a local host because no one can use it unless they have some way to interact with the contract using some other way, which there's stuff to do that, but it's kind of not best practice. You want to create front end and deploy it. So because we already did a Yarn build, now we can do a Yarn surge. Okay, Yarn surge is basically like a file survey, a small file service that allows you to basically deploy a front end anywhere. So we'll just say, okay, naughtystomach.surge.sh sounds good. So we're going to take our application, which has been kind of like compiled, push it to Surge, and then now any of you guys that are at home, you can go to this webpage, naughty-stomach.surge.sh. So apparently someone ate something, made their stomach hurt, I don't know. So let's go to debug contracts, and now we can see that our application has been fully deployed. It's on Goerli. It's got this building awesome apps. It's got all the functions that I want. And so now is the point where you're going to say, all right, we're not going to use burner wallets anymore. Let's connect to MetaMask. Okay, so let's hit connect. Let's connect to MetaMask. And let's go ahead and connect. And here we go. Let's switch to Goerli, switch to the network. And so now I should be able to interact because I have a ton of Goerli. I have 88 Goerli. So let's do something. Let's set a purpose of Kevin was here forever. Okay, and let's take the way, paste it in, and hit send. Now it's gonna be a little different. It's not like kind of test on localhost where you're just kind of signing transactions and they're going through and working. You're gonna get this little bubble that says your transaction started, and we've been able to deploy our app. And let's see if it works. Hopefully I was able to update the state of my smart contract. And anyone at home could go to naughty-stomach.surge.sh and yeah, send me a message on there. There we go. Transaction succeeded. Let's get refresh. There we go. Kevin was here. All right, cool. And the price has doubled. So if anyone wants to go home and do that right now, you guys can do that. Let's go ahead and log out. Okay, so if you're at home right now and you're saying, well, that was really a lot of information, but it was a good starting point for like how you get started, but I want to learn more. Talked to it already. Go to Solidity by Example. That will teach you pretty much everything that you need to know about writing smart contracts in Solidity. Speedrun Ethereum is the best spot for you to go to be able to test your ability to build a decentralized application on Ethereum as well. And sign up, connect your wallet, and go through all these kind of like challenges. Eventually, you'll get joined to the Build Guild and be a part of the Build Guild community. So yeah, I hope that was useful, and I'm going to stop now, and I want to give some time for people to ask questions. So let me do that, and we'll go from there.
Hey, so my question is, so like I see different tools that you use in Scaffold.eth, but what tools do you might want them to have additionally add to that program?
Well, Scaffold-eth is going to come with, the catalyst for you to be able to publish your smart contract to any testnet or in mainnet, right? So it uses hard hat. I guess there's alternatives. I wouldn't really say there's like things. There might be like additional React plugins that you might utilize on top of that. So what I would like to show you guys, let me share my screen again. If you go to Scaffold-eth and you go to the core GitHub project, there's a couple different repositories. The first thing is Scaffold-eth examples. And I guess what I would say to answer your question is there's probably someone who's thought of like, oh, well, I kind of want to do something a little differently with Scaffold-eth. You might be able to search for that in here. So like an example would be, I don't know, let's say that you wanted to use a certain framework, right? You don't want to use React, right? You want to use a different version of JavaScript, right? So you might use Next.js. You could search JS here, and there's a copy of Next.js instead of React.js. So there's different alternatives. I wouldn't really say there's anything that you need on top of this. It's more that you might want to do things just a little differently. Like you might want to use TypeScript, right? So here's the Next.js TypeScript build. You might want to use what's the other one? Forge. I forget what the other one's called. It's there's a different deploying tool. Like if you don't want to use hard hat, you could use I can't remember what the other one's called. So there's alternatives, but I don't really think there's anything on top of it that you really need to have.
Okay.
And by the way, there's also like, so there's Scaffold-eth examples. There's also Scaffold-eth challenges, which has all the challenges in here as well, like the readmes for that. And then there's also some examples in here as well. So like if you search here, you might find like, I don't know, let's say search NFT. There's like a ticket NFT example, signature-based auction example. So there's different, you might want to just search around the different repositories for what you're looking for. There's also Scaffold-eth 2 is here, which is the newest version of Scaffold-eth that's coming out soon. And they're working on that. That might be interesting to some people listening in right now. Scaffold-eth 2 is in a test phase. It's still under active development.
I got a question. I don't know if this is a stupid question, but what do you guys have like next on the like docket of like what you guys want to implement? I was thinking like, I don't know, you hear on the news all the time, like major hacks on especially bridges and other like Dapps people are making. Something cool would be like an AI, maybe like bot that would tell you like, hey, are you sure you want to write this? Like, if you do this, then like anybody can access the funds or something. Have you ever heard of anything like that? Or is that like something that anybody's thinking of like implementing to like help prevent people from writing faulty Solidity contracts or like with holes in them? Security wise?
Yeah, that's an awesome idea. I don't think we have anything in the pipeline for anything like that. Yeah, like some kind of like chat GPT, like plugin or something that allows you to, kind of like before you deploy any changes to mainnet, like it kind of verifies your kind of like source code a little bit or something like that, and like make sure there's no vulnerabilities. There's not a lot to, I guess, Scaffold-eth's learning path that focuses too much on security, but there's a couple things that will teach you about like game theory in that kind of speedrun Ethereum. So it teaches you like how contracts work and like how the blockchain works and stuff like that. But I think that we definitely want to create more parts of that kind of challenge that people will go through that is more security focused. I think it's a good idea. I think maybe we should talk about it and figure out what it would look like. And the cool thing is like I said, if you want to be part of the Build Guild, you can go through those first two challenges and write that, and you can get paid to write that. So if that's something that you want to work on, or even like a group of people want to work on, even just to build that would be really cool. And that's what's cool about the Build Guild is we're just all about doing stuff like that. So I'm throwing it back to you. You should build it.
Yeah, maybe this weekend for the hackathon, you know, we'll see.
There you go.
I'll get back to you.
Yeah, for sure. Yeah, and if anyone has questions, and like after this, I'm on Open Book. I'm on Twitter. I'm on Telegram as Kevin Jones Creates. So if you guys search me on there, Kevin Jones Creates, you can add me. But yeah, welcome to help you guys with anything you need. And I'm at a lot of events. I'll be at ETH Tokyo. I'll be at ETH Austin. Probably Consensus. Yeah, I'll be at a lot of stuff. So if you guys are around, come say hi. Any other questions you guys have?
Maybe it's just like a small logistical thing, but I was noticing when you opened up your like second account, when you're interacting with the first version, like before you deployed, was it not refreshing between like updates, or was that just for speed of the demo?
Yeah. So there's some like hooks in React. So if you know like React, you create like a hook, right? And like I think some of the hooks don't work properly, so you might have to manually refresh every once in a while. Most of the time, if you're dealing with like one account, yeah. So if you start building your app, yeah, you need to start thinking about your hooks early and figure out like, okay, well, like, so you know, and you know, I'm not sure how much you know about blockchain, but specifically with Ethereum, you know, you have your events, right? You have these events that happen, and that's kind of like how you know, like when you need to update your UI sometimes. There's another implementation, well, there's an alternative way to do that, and that's with the graph. If you guys haven't heard of the graph before, but the graph is like an API layer essentially for all of your like kind of like blockchain data or smart contract data. And so there is a cool tab, which let me share my screen again, and it's worth talking about. So if we go here, sorry, whenever I do Zoom, like I can't see anything here. Okay, so if I go to this last tab, subgraph, and we can see that it walks you through how to like deploy a subgraph. And it shows you how you can use the GraphQL API to query the data that you have. And then you could create your like React UI to basically be reactive based on the API calls. And it's a lot faster because like Ethereum events are like rather slow, right? Like you have to go out and get like, I don't know, whatever 100,000 events that your app has, and it can like make your app fall over. And so like this will allow you to just do one API call and like grab a ball, and then like, or like maybe it's a certain amount of time or the last so many that you want to do. And it will allow you to kind of like show your events here. And it also has an example. I wrote a good blog post on how you write subgraphs using Scaffold-eth. So if you guys search it, you'll be able to find it. Just search Scaffold-eth subgraph README, and I'll try to give it to, actually, maybe I can find it. Let's see. Okay, it's not as easy to find as I had hoped. But yeah, yeah, I'll see if I can find it and send it later to Lexi so you can send it out. But yeah, check out the subgraphs. And like I said, if you're building out your front end and you start building out this part, yeah, you'll want to create like a better kind of system for that.
That's awesome. The graph thing was going to be my next question. I like built a subgraph for a project a little while ago. I definitely wish I had like this at my disposal at that point. Yeah,
it's awesome, man. There's like a lot. So since I wrote the blog post and since we've implemented the graph into Scaffold-eth, there's a lot easier ways to do it. So I would kind of dig around a little bit on the graphs documentation, but you can utilize Scaffold-eth still. It just might be better for you just to use like the hosted service or actually deploy to like a testnet or something like that. But you can use the one that's in Scaffold-eth. The thing is, it uses Docker. And so it gets a little like tricky when you want to deploy it to a testnet, because then you have to like completely switch around the way that you're deploying. So I recommend if you're learning and you want to mess around with the Scaffold-eth and the Docker setup, it's cool. But I might recommend that you actually just try to do the graph separately. That might be a good example of something you might have to use in another way.
Cool. I'll definitely check it out either way.
Awesome. Cool. Well, hopefully that was helpful, guys. I know it was kind of probably fast, but like that's kind of like the shotgun method that I like to teach. Just yeah, this is how I do it. Try to just run through it real quick, and then you can watch the YouTube video later if you want to try to follow along. But yeah, hopefully that was helpful, and hopefully you guys learned something. But again, yeah, I'm open book. So if you guys have more questions, let me know. Happy to help.
Matthew, do you have a question?
I was just a little bit curious about like the way that like chain link oracles would interact with like Scaffold-eth. Like, are they pre-built into it? I was reading about the section that they had with like NFTs being deployed and stuff.
So there are a couple example. This is a good one that you could search for, like Chainlink. So if you go to like the Scaffold-eth, there's like a Chainlink build that someone did where they use Chainlink to deploy a smart contract and then get values from it using Chainlink as an oracle. So yeah, there's definitely integrations there. I think most of the stuff you're going to do is going to be, yeah, like probably the only one I've seen is through Chainlink. And there might even be some videos, like if you do a YouTube search for like Scaffold-eth and Chainlink, there might be one that Austin Griffith did with the developer advocate. I forget his name. He's a super cool dude, but the guy from Chainlink, him and may have did a video that showed how you do it with Scaffold-eth. So I would kind of start there and then kind of go from there.
Gotcha. Thank you.
No worries. See, Alexi, you're on it. Or Alexis, sorry.
Yes, definitely.
It's definitely the best Zoom support I've ever had. So
Thanks. All right. Well, thanks, guys. Kevin, don't hesitate to send me links so I can share them on YouTube. And yeah, really nice having you today. It was a chill and really interesting workshop. So we really appreciate the time you spend with us. All right.
Anytime, and if you need more help, just let me know. I'm happy to talk anytime. So
awesome. Well, see you soon.
Cool. Thanks, Kevin.
you guys, girls.